In lesson 6.5, we're going to be talking about exponential growth. Exponential growth is going to be happening when we have a quantity that's increasing by the same factor over equal intervals of time. So for example, if you have a population of bacteria that doubles in size every hour, then you're multiplying by 2 every hour, or you're increasing by that factor of 2 over a 1 hour period of time. That would be exponential growth. Or if something triples every 3 days, that would be another situation of exponential growth because you're continually multiplying by 3. So our learning goal for today, I will write, interpret, and graph exponential growth functions. So an exponential growth function is going to look like this. Y equals A times the quantity 1 plus R to the T. And in order to do this, you need to know what each of these pieces mean. So Y is going to represent our final amount. A represents our initial amount or our starting amount. R is what we call our growth rate. And we need that to be as a decimal. And then T is going to represent time. And just something to be aware of, this piece right here, this 1 plus R, we call our growth factor. So that chunk is called the growth factor. So what we can start off with is, we can just start off with an exponential equation, because I know this seems like a lot of material, but once we do a couple examples, it's actually not nearly as confusing as it looks. So let's say we have the function y equals 40,000 times 1.05 to the t power. And this is representing the population of a town T years after 2010. So Y is going to be the population T years after 2010. So like 2015 would be 5 years later. So if I put a 5 in here and solved for Y, that would tell me what the population was in 2015. So our first question is to look at this and to figure out what do the pieces mean. So what does the growth factor of 1.05 mean? Remember, if we were to break that up into the 1 plus R, this would be 1 plus 0.05. So this right here, that's another way of writing 5%. What that tells me is my population is growing by 5%. Remember, R represents our growth rate in decimal form. So our growth rate is 5%. That means each year we're getting 5% more people than the year before in this town. So that would be the first, question is, what is the percent increase? Or by what percent does the population increase? And you would say 5%. My next question is going to be, what will the population be in 2017? And it can be tempting to plug in 2017 and for T, but remember T represents the number of years after 2010. So that means when T equals 7. So what I would do is I have Y equals 40,000 times 1.05 to the 7th power. And then I'm going to real quick grab my calculator, plug this in, and figure out what I get for my answer. Okay, so with my calculator, I do 40,000 times 1.05 to the 7th power, and I get 56,284. Now you might be asked to round that, like maybe round to the nearest hundred or that sort of thing, so you'd say 56,300, but that tells me what the population would be in 2017. So I would like you to try this problem on your own. You borrow $500 at an interest rate of 4% compounded monthly. For part A, write an equation showing how much you owe after T years. And for part B, how much do you owe after 3 years? So pause, try and come up with your equation, and then hit play and see if you're on the right track. So we're going to use y equals p times 1 plus r over n to the nt. And I think it's a good idea to just list what each of your variables are. So p is how much we borrow to start off with. That's 500. R is 0.04, that's 4% as a decimal. And we're compounding monthly, so that's 12 times a year. T we're just going to leave because we want to know when it happens after T years. So I'm going to plug that in. Y equals 500 times 1 plus 0.04 over 12 to the 12t. And then I'm going to do 0.04 divided by 12, and we end up getting 0.003 repeating to the 12t. So if I simplify that even further, it's y equals 500 times 0.003 to the 12t power. So what I would do is I would hold that number in my calculator, and then when I go to solve this problem for step 2, I'll show you how I'm going to carry that answer over. So this is my formula. Y equals 500 times 1.003 repeating to the 12t power. And I want to know after 3 years, so I need to put in 3 for t. So y equals 500 times 1.003 repeating to the 12 times 3 power, or the 36 power. So what I'm going to do is I'm going to take this answer, I'm going to add 1 to it. That takes care of what's in parentheses. And then remember that my next step is to do the exponent. So I'm going to raise this to the 36th power, and just by pushing the caret button, it says answer. That means it's taking this answer and pulling it down. I raise that to the 36th power, and I multiply that answer by 500. And I get y equals 563.64. So I borrowed 500 to start off with. After 3 years, I'm going to owe $563.64. So there's another example of how to do this, but in this case where we're compounding monthly instead of yearly.